Avi, always a pleasure to speak to you. How's things?
Thanks for having me. Very hectic.
Well, I appreciate you taking the time out to join me once again. And I'd like to kickstart this off by asking you about the May 1st event that you were on a panel for. This was hosted by the UAP Disclosure Fund on Capitol Hill, the Understanding UAP event. I just wanted to get your, first of all, your general views on how the event went.
Um, I thought we delivered an important message. My primary interest is in the science of unidentified anomalous phenomena. And the reason I do that is because there is a chance that some of the unusual objects that are noticed in the sky may be of extraterrestrial origin. Even if one in a million or one in a billion of these objects is not from this Earth, that would be the biggest scientific discovery ever made because it will have huge implications for our future. It could allow us to have a quantum leap in our technological capabilities by noticing technologies or scientific insights that we didn't have a chance to imagine as of yet because we only had 1 century of modern science and technology. You know, the chips that are currently used, state of the art chips for artificial intelligence systems, they are designed based on our understanding of quantum mechanics, which was discovered exactly 1 century ago. That's it, 1 century. And as a scientist, I lived through half of that history. So my scientific career, which is quite amazing from the start of the career when I was a student to the present time, spans half of human scientific history in which we learned about uh, general relativity, the way space time is curved, and we call it gravity, and uh, quantum mechanics. These are the two pillars. As of now, they were not unified in a single theory. We are lacking an understanding of quantum gravity. So there are clearly holes in our understanding of reality because in some domains of the physical reality, when we do experiments, they agree extremely well to exquisite precision with predictions from quantum mechanics. That's when gravity is not present or not significant at the quantum level. On the other hand, when we consider gravitational experiments, the most exciting one recently was the detection of gravitational waves from the edge of the universe. There we confirm Einstein's theory of gravity to exquisite precision. But again, there, quantum effects are not important. And we just detected the gravitational signals from systems where quantum effects are not significant. Where we are lacking understanding is when quantum mechanics and gravity have an important role to play. That happens when a particle has enough energy so that it's confined within its own Schwarzschild radius, the radius of a black hole. So when you create a black hole out of a quantum particle, you know that obviously requires understanding of quantum gravity, and that is called the energy corresponding to that is called the Planck energy, or if you can translate it by dividing the energy by the speed of light squared to get a mass, it's called the Planck mass. And we know that if we ever conducted experiments at such a high energy, we would need an understanding of quantum gravity, or alternatively, you can imagine figuring out the rules of quantum gravity from experiments like that. So other civilizations may have reached the technological level to build particle colliders that reach this energy, or they have some other ways of inferring the rules of quantum gravity. We don't. So there is a lot for us to learn, and maybe by observing vehicles that behave in ways that we don't fully understand, we can make steps in that direction. So that's the reason, as a scientist, that I'm interested in that. But the more important thing is, if the Department of Defense or the intelligence agencies have objects that they cannot figure out in the sky, which is admitted by both of them. I mean, there were reports delivered by the Director of National Intelligence that there are unidentified anomalous phenomena. And this clearly implies that, something needs to be figured out. And it could be of national security importance if it involves technologies that adversarial nations are employing. And For example, during this briefing, Chris Mellon pointed out that the government invests billions of dollars in sensors, and so there is no lack of data. Well, the point is that from a scientific point of view, you could have excellent sensors, but if you don't filter the data from them correctly, if you don't apply the most advanced artificial intelligence algorithms, if you don't employ the most brilliant scientists that you can, you might not figure out what is happening. Okay, so it's not just, the situation is similar to building a stadium where you have an amazing uh, football field. Okay, but you can invest billions of dollars in that stadium. If you don't have good players, you will not enjoy the play. Okay, so the same is true about science. You can have instruments, facilities, and claim that you invested billions of dollars in those facilities. It's irrelevant if you don't have the very best minds to analyze what you're finding, or to actually find something anomalous in the best possible way. Maybe these instruments are not really designed properly. You really need brilliant scientists to get engaged, and until you have them, you don't accomplish the goal. So what I'm saying is, with an investment of $1 billion, in principle, we can establish a program similar to the Manhattan Project. That's what I suggested at the opening of my remarks, where I'm quite confident that I can attract the very best scientists to join this project, the way the Manhattan Project attracted the very best physicists, and they accomplished the goal of building an atomic weapon. Okay, so if you get the best minds, you can get the best results. If you don't have the best minds, suppose the Manhattan Project would have included people from government, and someone would argue, just like Chris Mellon, oh, they have the money, don't worry about it, they'll figure it out. No, they will not figure it out on a short time scale. You really needed scientists like Enrico Fermi, like Richard Feynman. These were necessary, and of course Oppenheimer. These were necessary to get the job done. It's not just about money. It's about the level of the people who work on the project. And in order to attract the very best scientists, you need to invest funds in a project that has access to the very best instruments, to the development of nowadays artificial intelligence software. And my point is, suppose we don't find anything extraterrestrial. Suppose it's all human made. I would feel good about it, because this project would be used later on. All the output from the project will be used by the Department of Defense to protect the nation. Okay, so it's a win-win situation. You attract the best minds to work on a problem that the government right now cannot figure out, and that will be later useful for the defense of national security. And so that makes a lot of sense for me. Now, $1 billion to some people sound like a lot, but actually, it's only 10% of the funds allocated to the Webb telescope, or 10% of the funds allocated to the Large Hadron Collider. These are scientific projects. It's 10% of the amount of money that was asked for the next big telescope in space, the Habitable World Observatory, that would at best, according to plans, detect the chemical fingerprints of microbes in some 25 exoplanets. Now you tell me, investing $10 billion in this ambition, that will be carried out by NASA within 20 years, versus investing $1 billion in a project that could serve national security if nothing scientifically exciting is found. I mean, to me, it sounds like a no-brainer. I mean, you really want this to be resolved so that you don't worry about objects in the sky. This Chinese spy balloon was huge, tens of meters, and was barely recognized at the time. And citizens alerted to its existence. We don't want to be in that situation. We want to understand every drone that flies, that is not hours, okay, above the US. We want to know what is flying above the US. And if there are unidentified objects, it means that something is not working, and let's figure it out. Let's use the best scientists to figure it out. And the icing on the cake would be that the discoverer of something from outside of Earth, would get a Nobel Prize. That's not a bad thing if the Department of Defense happens to be involved in a Nobel Prize winning exploration.
Yeah, I mean, one of the other panel members was the physicist Dr. Eric Davis, and it's alleged that he's worked in some way on UAP programs. I'm not sure what capacity, but he said some pretty far out things during his time on the panel, and I just wondered what your thoughts were on what he said.
Yeah, so as a scientist, I can only respond to evidence. It's very easy to tell stories. We know that. We know that because people, sometimes have wishful thinking. And we know that also because some people on death row were exonerated when DNA evidence was found. Now, the people that testified against those that were on death row, they were very convinced that they're guilty. Very convinced, sure about that. They testified under oath, yet the DNA test indicated that they were wrong. Okay, so all of this is to say there is no escape from direct evidence. You can't ask me to believe stories without showing me the evidence. Okay, so if I were to witness the kind of crafts and their content that Eric Davis referred to, I would tell you what I think about it. I was never exposed to that. If the government has it, I would love to see it. If it was collected 50 years ago, it's of no significance to national security, even if it's from an adversarial nation, right? Because by now the technologies are so much more advanced that whatever happened 50 years ago is irrelevant. So the key question in my mind is whether, if something was retrieved, could it be human made? Could these pilots that he was talking about be actually humans that they were so um, distorted by the crash that it looks as if they were unusual creatures? I mean, I just don't know if something like that exists. I can imagine that there are retrieval and reverse engineering programs in government. That's for sure, because every now and then you capture, in combat zones, you capture technologies from uh, other nations, and you want to figure out what they mean. So you want to reverse engineer those. So there is no doubt that the government retrieved and reverse engineered technologies. The only question is, are these human made or not? And to figure it out, I need to see the evidence. And I would love, by the way, to help government figure it out, whatever they have. If they do, it could save us a lot of time, because they collected stuff over half a century or more, and it will just take time to do the same openly in the scientific way. So if they have something that they collected over the past decades, I would love to help them interpret that. But I was not presented with that, and just hearing Eric Davis talk about it is not enough.
So, if you were, for example, let's hypothetically speaking, if you were approached by the government or a contractor and said, Avi, we would like you to take a look at this non human intelligence craft, but you're not allowed to tell anyone, you've got to sign a non disclosure agreement, because you've always been very clear that you'd like to be very transparent with any of the work that you do, especially with the Galileo project. So, with that, what would you do under that situation?
Well, if I'm placed in that dilemma, I would choose to know, just because that if you see me stopping my pursuit of the research, it means that I already know the answer. So if I know the answer, I can spend the rest of my life on a beach. As a scientist, you could just a very simple model of me as a scientist is a curious kid. I'm just curious about the answer to the question. I want to figure it out. and I will do my best to figure it out, based on evidence, not what the adults in the room are telling me. On the one hand, where they could completely dismiss the possibility that we might be visited, and not when believers tell me their stories. I actually want to see the evidence because that's the only thing that will convince me. It's a matter of common sense. Okay. Now, if I know the answer, there is no point in me trying to find it on my own. If someone shows me clear evidence, so I will, I will not need to pursue it on my own. And if you see me stopping, one possibility is that maybe I decided that there is no point in continuing it. The other possibility is that I already know the answer. But as long as you see me eager to figure out the answer, you know that I'm not signed on any such agreement.
There seems to be a bit of a funding dilemma because you think about, there is not a lot of data public about these alleged crashes or these craft. Yet you look at something like dark matter, which, really hasn't been proven yet. There's a lot of funding, there's a lot of scientists looking at it. So why are UAP not seen in the same light?
This is really interesting, an interesting question that I actually wrote about this morning. I wrote an essay. There was a poet that lives in New Zealand that sent me a book with poems inspired by my scientific research. And he's not the first artist. That there was a composer that wrote a piece of music inspired by my work on Oumuamua, the first reported interstellar object that appeared anomalous. It was discovered by astronomers. Nobody doubts that it exists. It's just that we don't know what it was. It was really strange. And then another musician, a composer, wrote a second piece about my work on that. And so now there are two compositions. One was played by a symphony orchestra, and the second was played at the Harvard Natural Museum just last month. And in addition to that, there was a sculptor, Greg Wyatt, who donated two sculptures inspired by the Galileo Project that I'm leading. And there was a play that was written by a playwright, Josh Ravech, about my work, and that includes the interstellar meteor as well. And it's called The Piece of Sky, a play. And now there is this poet. So there are lots of artists. And actually, just this month, I met many important creators in the arts, in the business world. Just over the past month, people, aside from the people in Congress that I met, Anna Luna and Tim Burchett, that were very, inspired and by the work being done. I also met, for example, Jerry Bruckheimer. He is making apparently a film about related topics. Adrian Brody, George Lucas, Demi Moore, Trevor Noah, Margot Robbie, Michael Dell, Ted Decker. All of these are very creative minds in business, politics, and art, and they resonate with thinking outside the box, whereas academia is threatened by it. And the question is why? And after all, tenure in academia was supposed to secure freedom of thought by providing job security. But instead of fostering risk-taking, the ambition to receive honors and grants tightened the academic herd mentality over the decades and established a culture of virtue signaling in research and in campus politics. And, so I think most of my colleagues are afraid of taking risks. And moreover, there is something else that, I do see scientists imagine things with no evidence to support them, like extra dimensions or specific types of dark matter. But there is something else, perhaps the human ego, that triggers resentment, pushback against the notion of superior alien intelligence. For some reason, that is considered speculative, and people just, I mean, within academia, people are not engaged in either funding it or supporting it academically. So, for example, currently the highest priority that the U.S. astronomy community decided about this decade is the Habitable World Observatory that will cost more than $10 billion, will be constructed within 2 decades by NASA. And as I mentioned, it will search for microbes in based on the chemical fingerprints that they leave in exoplanet atmospheres. And frankly, I find the microbes boring, uh, much more boring than finding evidence for intelligence. And moreover, we can learn from a more intelligent species, and the evidence could be far more conclusive, because these molecules, the biomarkers, might be produced by natural geological processes, whereas if we find evidence for a gadget near Earth, it will not only inform us that life exists, but also that intelligence exists. So my argument is we should hedge our bets. Scientifically speaking, within the scientific community, we should dedicate at least a few percent, maybe 10% of the budget to the search for artifacts near Earth. But instead, it's zeroed in the federal budget compared to $10 billion. So that it's really that thing that prevents us from learning something new, because without funding, without allocating uh, effort, without having the smartest scientists engage in this search, we will not find anything.
Well, let's say, for example, if you were offered from a generous benefactor an unlimited budget for this kind of program that would be, to look for these objects, not so much the Galileo project, but more, could you entice the best scientist if money was no option, or do you think they would still run the risk of ruining their reputations?
No, I think deep down, a lot of people think that it's exciting. I hear that from every day from people. I get dozens of emails from people who want to get engaged, but I cannot support them. And I also get a lot of fan mail, people sending me photos that they want me to sign for them for their collection. And there is a huge amount of interest and support for this. And currently, what is limiting the research is the lack of funding. I mean, whatever the Galileo project is doing is really limited because I cannot hire more people to do the work. And it's not just more people, it's the very best people that are currently doing something else. So if you want to entice them, I'm very confident. I was director of the founding director of the Black Hole Initiative at Harvard. I'm currently the director of the Institute for Theory and Computation at Harvard. And for 9 years, I was chair of the astronomy department of Harvard. And I've been also the head of the advisory board, scientific advisory board for the Starshot project that aimed to send a spacecraft to the nearest star within our lifetime that would reach the destination at a fifth of the speed of light. And I also chaired the board on physics and astronomy of the National Academies. So I really know the material. I know how scientists think, and I know that I can attract the very best of them to a project like that if funding is available. Not at the current level. I cannot do that at the current level. But if the funding went above 100 million, more appropriately at the 1 billion, this could be the way for us to figure out very conclusively what these unidentified objects in the sky are. And some people argue we already know the answer. And my reply to them is no, you don't. Because the only way to convince everyone that this is real or that there is something beyond human made objects in the sky is to get high quality data beyond any reasonable doubt that shows it's technological and not human made, or to get a hold of such material. So it really requires effort. You can't sit on your chair and just express your opinion. That doesn't get us anywhere, because we've been in that discussion. There are people who are believers, people who are skeptics. This can continue forever. And of course, you might regard it as just fun to argue one way or another. I don't really enjoy that argument with believers or skeptics. That is not really what I would like to do. I would just like to figure out the answers, so then they would disappear. Both the believers or the skeptics will just disappear. Why? Because the evidence would be so clear that there is no point in arguing about it. The Vatican admitted that Galileo was right in 1992. That was a bit late, 2 decades after we got to the moon, but nevertheless, they admitted it. And you may ask yourself, how is that possible? Because they were killing people for heresy. They put Galileo in house arrest, even though they highly respected him ahead of his statement that the Earth is not at the center of the universe. So the point is, people can insist on an opinion, but it isn't really relevant. I don't care what we think, what one group says, what the other group, what Eric Davis says. That's irrelevant. Let's look at the evidence. It's not about Eric Davis. It's about what the materials are, and the only way to figure it out is to have access to them. And so it's really the evidence that we should seek. And how can we get better evidence? Well, one way is to continue this struggle with government, declassifying things they hold under. The other possibility is simply to get better data rather than obsess with what happened in the past. We can do that. I don't see it leading anywhere. We haven't yet seen the conclusive evidence. The other possibility is simply, if these things are out there, we will be able to see them. We will be able to figure them out. We just need the investment of funds and effort, having the best minds dedicated to the problem. That's my suggestion. And I really hope that this will be taken into account when the defense budget for 2026 is formulated, that there will be an allocation to research. It doesn't need to, I'm not talking about the Galileo project, I'm talking about the money that I will be personally using within the project. It's more about the Department of Defense figuring out a puzzle that is worrisome from a national security perspective. And my point is, you can't figure out the puzzle unless you employ the very best minds in the world. And I can do that. I can get those people if the funds were allocated to this task.
Sure. Yeah, that would be very nice. Well, let's move on to the Galileo project, because, this is been going for a few years now. You've deployed a sensor suite, and I just wondered if you could give us an update on maybe the data collection, anything interesting. Have you, developed newer sensors? Have you upgraded it over this time?
Yes, definitely. So we started with one observatory at Harvard University where we did all the testing. And that observatory is providing us with 1 million objects per year in the sky. We analyze them. We can tell that less than a few percent are anomalous. Okay, so obviously, there are objects we can figure out. Now, the most important thing in getting to the most anomalous object is to figure out distances, because otherwise you just see an object moving across the sky. You don't know at what distance, you don't know the speed, you don't know the acceleration. So we are now getting into the ability to figure out distances using the method of triangulation. When you have multiple units within the observatory that are looking at the same object from different directions, you can figure out the distance. Okay, and that's what we are starting to do right now, and hopefully within the summer we'll master this technique. So that would actually allow us to identify very unusual objects if they move extremely fast or accelerate very fast, because we will know the distances. So in addition to the test bed of the observatory we have in Massachusetts, we already assembled another copy of it, an observatory in Pennsylvania. And that is also collecting data now. And then this summer, probably by the end of the summer, we'll have a functioning observatory also in Nevada. And I received funding for all three observatories, which is great, from donors, people who are really excited about it. There is another observatory that we are planning to construct within 2 years in Indiana. That will be in a STEM education center for young students. And I see that as an important priority because this will be a way of letting them analyze the data and educating them about one of the exciting frontiers of science, which is the scientific study of unidentified objects near Earth and trying to figure them out. And that would include also near Earth objects that are just passing through the solar system, interstellar objects as well. So I'm excited about the possibility of bringing in young people, the young generation, because they are open-minded, they are less biased by prejudice than senior people. And that would make 4 observatories altogether. And that should give us access to a few million objects every year. And we are analyzing the data with machine learning software that is trained on identified objects like airplanes, birds, leaves, stars. And the goal is to have the machine learning software run over the data and analyze it in real time quickly. At some point, we might engage also the public in the analysis, but at the moment, we are still developing the artificial intelligence software, so it's a work in progress, and we are planning to use it in all 3 sites, Massachusetts, Pennsylvania, and Nevada. So, in other words, starting this summer, we'll start collecting data on a few million objects a year. Just think about the number compared to hundreds of reports that AERO, the All Domain Anomaly Resolution Office, was attending to. This is a completely different regime in terms of our ability to identify unusual objects. And obviously, the key is also to place the instruments in different locations so that we can sample whether there is evidence for such objects everywhere or just near sensitive sites. I know that, it was mentioned that AERO also developed a system which probably was inspired by the Galileo Project. I haven't seen yet their data, but the more eyes we have on the sky, the better.
Absolutely. And you mentioned there, you're detecting anomalous objects. What does a true outlier look like in that data? Because you mentioned it's able to determine aeroplanes and birds, but can it really pinpoint down even further with drones and other objects like that? And then what else does an outlier look like in the data?
Yeah, I still think we are, the most of the unidentified objects in our sample are probably known objects that we just didn't classify because we didn't have distances. So I think once we have distances, we'll get to the few that are potentially truly anomalous. But what I'm emphasizing is that it's a small fraction of the population of objects in the sky, and the key is to get rid of 99.99999% of the objects, and that's why this requires hard work, because a lot of people just look at the sky, see some bright light, and say, "Oh, that's a UFO, that's a UAP." No, that's not. It's probably something like that is known. So the point is that you really need to, in order to figure out the outliers, you really need to look at a lot of objects that are known, because only then you realize, oh, that is really an outlier, because you never see such a thing out of millions of objects. Something like that never happened. So you really need to monitor the bulk of the population and realize that it's a mixed bag. You can't just say, oh, the first object you look at would be an outlier. So that's why the work requires effort and time and mostly funds. I could scale up the level of research by orders of magnitude if we had more funding.
Sure. And what sort of signs would you be looking for to determine whether something doesn't appear to be human made, or certainly the kind of technology we know that we have. You know, you look at Lou Elizondo has mentioned the 5 observables. What sort of what does the machine learning use to, or what does it look for specifically?
Yeah, it's not. It's um, if the object moves in a speed or accelerates beyond the envelope that human-made technologies allow, that by itself would be sufficient. You don't need a lot of anomalies. You just need the object to move faster than any human-made craft or vehicle, or accelerate in ways that no human-made object can accelerate. And I mean, we know that artillery shells can accelerate at thousands of g. So you really need to see something that is behaving in ways that cannot be associated with human-made objects. And it's possible we will find some. I mean, because the government does have some reports that look anomalous, except that the data is not sufficiently good. There are eyewitness testimonies by reliable people that indicate objects that behave in ways that are quite anomalous. But we really need data from instruments, and that's what I'm after. And the more observatories we put and the more time we spend on it, the better will be the limits that we place on anything anomalous. And as I said before, if the government already retrieved something of great interest, that would save me a lot of time. I will not need to search if they have it.
Yes, of course. So, let's say your equipment picks up an object moving at, speeds which, don't seem logical to us. You've got video, let's say. What other sensors are there on the suite? Like, how many data points would you have for that one sighting, let's say?
Yeah, so first of all, if we have an image, that's very helpful because we can tell how the object looks, and rather than it being just a point of light, that's not very informative. And then, the way that it maneuvers. Okay, so if it makes sharp turns with accelerations that exceed what human-made propulsion can accommodate, that by itself would be extremely anomalous. We will verify the data. We have instruments, sensors in the infrared, optical, radio, and audio at the moment. And we also have a magnetometer that can detect magnetic fields. And we're thinking about some novel signatures. In fact, there was a professor who approached me and asked me to be her mentor in developing new probes of UAPs. She is about to get tenure, so she's in an advanced professorial track, and approached me and said, I would like you to mentor me about how to apply what I learned as an experimentalist to the study of UAPs. And I agreed to that. We applied for financial support. So this is an example where you see someone, a physicist, a top-notch physicist, who is very excited about pursuing this. And two of my postdocs were very excited about an opportunity to study UAPs, and they didn't have that opportunity until I announced the Galileo Project, and now they are my postdocs. So that's what makes me optimistic, that once there is funding for this research, it doesn't need to be within the Galileo Project. It can be handled by government in other ways. But the point is, I would love to be flooded with data. That will be my great pleasure, not flooded with by statements from people that we already have, and we know that we cannot trust a lot of them. What I want to be flooded by is real data, and because once you are flooded with data, there will be no way for skeptics to brush it under the carpet. It would be so clear, just like it is clear that the earth is not at the center of the universe. So the Vatican has to admit that. Believe me, if the data was sparse and inconclusive, the Vatican would not make any statement that confirms that Galileo was right. The only reason they made this statement is because it's unreasonable to argue otherwise, given all the data that we collected by 1992. So they had no choice. Politics is not coming to the rescue in a situation where the evidence is clear. Okay, you can make your way and make false statements when the evidence is unclear. So my wish is to just be flooded with data, so we will know exactly what every object in the sky is, or any object that crashed somewhere is. And at that point, I don't care what the answer is. I just want to know the answer, and then move on. If all of these objects are manufactured by humans, so be it. That's good to know, because now you know how to protect the nation with better instrumentation, better artificial intelligence algorithms. If it turns out that one of them happens to be extraterrestrial, well, the Nobel Committee will take it into consideration.
Sure. And speaking of data, you've mentioned in the past of a new observatory being built in South America. Is it Chile? I can't quite remember.
Yes, the Rubin Observatory. It was funded by the National Science Foundation and the Department of Energy, and it has a camera that is 3.2 gigapixels, so 1,000 times more than your cell phone camera. It will start operations in August 2025 with commissioning data at first, but eventually it would scan the entire southern sky every 4 nights. And it could find, in principle, UAPs, because it will just appear in the data, or it could find interstellar objects like Oumuamua. Every few months, an object like that should appear based on estimates of the sensitivity of this survey telescope. So I think the year 2025 is likely to be exciting, because on the one hand, we will have millions of objects that the Galileo Project observatories, 3 of them, are monitoring starting in August 2025. Around the same time, the Rubin Observatory will start providing us with data. And my hope is also that we will be able to go to an expedition to collect bigger pieces of the interstellar meteor IM-1 that collided with Earth back in 2014. And I already led an expedition there, and we collected tiny spherules, molten droplets, and found that the chemical composition of 10% of them appeared to be different from solar system materials. But we want to find bigger pieces that will tell us something about the nature of the object, the structure of it. And that will be an expedition that will use a robot, a remotely operated vehicle that we put on the ocean floor with a video feed, and it will cost $6.5 million. We have the vessel, we have the ship, we have the robot, the ROV, we have the team, everyone is excited. We just don't have the funding. So here is an example. We will go there, do the work, all the work needed. It's just that we don't have $6.5 million to do it. And so once we get that money, we will do it. And the hope is to trace the nature and the origin of this interstellar object, which had a very unusual material strength, tougher than all hundreds of meteorites that were cataloged by NASA over the past decade. And it also moved at a speed that is higher than 95% of the stars in the vicinity of the sun. So there is a chance that it was technological in origin, but the only way to find out is to find sort of the bigger pieces in the wreckage at the bottom of the Pacific Ocean. Regarding the first expedition, there will be a Netflix documentary coming out by the end of the calendar year, I hope, around that time, that documented our first expedition. And I think it will be very interesting for people to watch. I'm also writing a book to be published by MIT Press on the expedition. And so there are lots of things in 2025 that will be exciting to wait for.
Yeah, absolutely. And with the spherules, I know you had a lot of pushback at the time, and you came back and you'd analyzed them, and there was quite a bit of pushback. Did that all get kind of ironed out, or are there still people who are like, not on board with the results?
Well, here these people behave just like, the some people in the UAP community behave. They have an opinion. Okay, so they will tell you, oh, they just found coal ash, but we actually looked at the chemical composition and it's not that of coal ash. Okay, they don't have any access to the materials. They just say it could be. But so, and then they said, oh, you went to the wrong place because some seismic signal near that place might have been a result of a passing truck. Okay, but the point is that we went to that place because that was the fireball location identified by US government satellites. They saw the explosion, the light, not the seismic signal. And the explosion released 1% of the Hiroshima atomic bomb energy. So you ask yourself, can a truck release 1% of the Hiroshima atomic bomb energy? No. So how can people argue that? It's basically a lie to say that we went to a place based on seismic data. That's a lie. And some reporters simply repeated that. And I said to those reporters, I said, if that's the way you describe science, which is supposed to be evidence based, how can I believe anything you say about politics? And it's really unfortunate, but there are people who are trying to muddy the waters and claim that they don't see anything. And they don't have strong arguments. It's just that they are raising possibilities that are not substantiated by the data. So we went to the place where the explosion took place. We found a chemical composition that does not look like anything on Earth, like coal ash, as was claimed. There was also the claim that by people that said, "Oh, we shouldn't believe the U.S. government data," but the U.S. Space Command went back and analyzed the data and concluded that the object was interstellar. And so, what can I do against people that make the point they don't believe data? I mean, they behave just like the church in the days of Galileo. They just don't believe the data. Okay, well, what can I do about it? Any data could be, you could have skeptics that don't believe it. This is a one-time event, and the government went back and looked at the data, and they issued a letter to NASA saying that it is interstellar in origin. So these are the kinds of pushbacks that I get. My hope, we are now analyzing isotopes. My hope is we will find that the age of the sample that we retrieve is different from the age of the solar system. And isotopes cannot be doctored. You can't change the nuclei of atoms. And so if we find the isotopic abundances that are outside the range that the solar system accommodates, we will know it's not from the solar system.
Is there a chance that it was naturally formed outside of the solar system? Like, is there a percentage to it being
Oh, yeah.
naturally formed outside the solar system, or genuinely
Oh, no, there is.
technologically manufactured by somebody advanced, maybe?
No, so there is a possibility that it's natural. In fact, I wrote a paper about it, suggesting a possible scenario that would give the chemical composition that we found. This paper was peer-reviewed, published, but none of the journalists who reported about the criticism of the work bothered to report about it. We had a press release, but nobody cared. But we don't know at this point if it was natural or artificial. And because these molten droplets that we found, they are missing volatile elements that evaporated during the explosion. And if you really want to figure out the full composition of the object and the full material structure of the object, you really need to find bigger pieces. And that's why we want to go again in this expanded expedition to find bigger pieces, because they would help us crack the puzzle and figure out conclusively whether it was a rock or something else.
Yeah, no. What was it in the initial data from this object that attracted you to it, and then the possibility of it being technologically developed, let's say? Because, obviously there's got to be a lot of meteors and things in the sky, but What was it about this one?
Yeah, this is one in a thousand kind of objects that come from the sky. And it was roughly probably about half a meter to a meter in size, based on the amount of energy that was released from it. And what was unusual about it is that it was moving very fast. Actually, it came from behind the Earth at 40 kilometers per second. So the Earth moves around the sun, and it came behind the motion of the Earth around the sun. So it was at 40 kilometers per second, which is a high speed for a meteor. Uh, but if it were to collide head on with Earth from the opposite direction, it would have moved at 90 kilometers per second. Would have been an amazing fireball, much more than the one, at least 6 times brighter. Okay, um, so. So this object was moving very fast close to Earth, but relative to the sun. But also, when you extrapolate back in time, you can figure out the speed by which it was moving outside the solar system. So the fact that it was moving fast implies that it's not bound by gravity to the sun. The sun cannot keep it bound. But even outside the solar system, it was moving at 60 kilometers per second relative to the so-called local standard of rest, which is the rest frame of the Milky Way galaxy. And that is faster than 95% of the stars near the sun. Um, so it's actually not easy to explain such a high speed, and I had difficulties finding a scenario, but eventually I did find the scenario to explain it as in a natural way, and that is by disrupting a planet, a rocky planet like the Earth, when it comes very close to the most common type of stars, dwarf stars that are very compact. You can spaghettify a planet, and half of the material, I mean, you basically melt it into a stream of molten rock, and then eject half of it to interstellar space at as it turns out, at 60 kilometers per second. So I did find a way of explaining the high speed naturally, but it could also be a Voyager-like meteor. And then the second thing that was anomalous is that it exploded only in the lower atmosphere, about 20 kilometers over the Pacific Ocean. So that implied that the object had a very tough material in it that uh, maintained its integrity under extreme stress, and no other meteorite ever in the NASA catalog of a few hundred of them over the past decade ever was able to sustain such high pressures. It was at least 4 times above the material strength of iron meteorites. So what was it? And that's still a puzzle. And I very much hope we will get the funding to be able to address this question.
That would be fantastic. Yeah. Well, listen, Avi, I'm going to leave you on this last question, a bit of a fun one for you. If you were to choose, or given the option to either discover a genuine anomalous object such as a Oumuamua again, or a UAP in low Earth orbit or atmosphere, which one would excite you the most?
Oh, of course, UAP, because Oumuamua it wasn't clear that that there is an engine or anything functional in it. I suggested that it's being pushed by reflecting sunlight. So it's basically a broken piece of something, or like an empty trash bag, or a light sail, or something like that. But in the case of UAP, we're talking about an object that is maneuvering, that is functional. That is far more exciting, because then you can ask, okay, well, what is the intent of this object? Does it have a brain? Is there an artificial intelligence in it? And that could teach you something about the sender. If you find just space trash that is not functional, it's really hard to tell what the original intention was. It's just trash. If you see an empty trash bag in your backyard, you don't know what the trash bag was supposed to be used for. But if you find, on the other hand, some drone in the backyard, then you know that someone is aiming to collect information, or to do something else. So yeah, obviously a UAP would be far more exciting, but at the same time, there are interstellar objects flying by. There are a million of them the size of this meteor that I mentioned within the orbit of the Earth around the sun at any given time. It's just that we can't see them unless they collide with Earth, because they are they're very faint. They reflect a small amount of sunlight. And I suggested actually that if I had $1 billion, I designed the characteristics of a space telescope that would search for those and could figure out whether among the rocks there is any technological object that came from another civilization. So, if funding was available, one can imagine a space telescope dedicated to the task of looking at objects that are not coming very close to Earth, that are just passing within the orbit of the Earth around the sun. And we are using the sun as a lamppost. It's much easier to find keys under the lamppost.
Very true, very true. Well, Avi, as always, it's an absolute pleasure to speak with you. I thank you so much for your time today.
Thanks for having me.